Hey, how you doing? What's up? Let's talk about 2.5s. Ready, set, go. Ready. A little bit of a throwback. We're comparing 10 to the x power with log base 10 of x. Make a list of characteristics for each function. Oh, what a privilege this will be. There's a lot we can say. I mean, we could say that for 10 to the x power, its domain is all real numbers. You could say that your range starts at 0 and then goes to infinity. You could say that it's an exponential function. Check that. Super good. You could also say that there's a y-intercept. Where do you think that y-intercept is? Just at a glance. 1. Not bad. Couldn't have said it better myself. You could say that this is an increasing function. I think that's a pretty safe thing to assume because it's going up and to the right, and we'll assume that it keeps on going in that direction. Hope you agree with me there. Is there anything else we could say? I'd say that's pretty good summary, don't you say? And then looking at the inverse of this, we can say some similar things with log base 10 of x, but now we would say that our, what can we say? We can say that our range is all real numbers. We can say that our domain is exponential. We can say that this is a log function. We can say that we have an x-intercept at 1, 0. Notice, not a y-intercept. You could also say that it's increasing. I think those are some pretty good characteristics, if I do say so myself. In the next few questions, you'll be asked a plethora about logs, just to kind of summarize what you've seen so far. This is saying every graph of the log function, log of x, will contain the point 1, 0. What do you think? Is that true or false? I'm going to say it's false. I'll show you how. If you have log of x and you move everything to the right 1 unit, it's not going to hit 1, 0. Because you're going to say you're going to have log base 10 of 0, and good luck trying to find an answer for that. Both have vertical asymptotes. I'd say that's false. Just the logs do. Logs do. Remember how they started low and then went up and to the right? There was a vertical asymptote there that said, hey, you can't go past this. You can't do that. You can't hop that fence. I will leave 5 to you. And let's see what else is asked of us. I think a lot of this is, yeah, just building it off. They're definitely inverses of each other. You've seen this in chapter 2, unit 2, and also unit 1, honestly. So that's something you should know. The range and the domain did switch. The graph of g of x will never reach 3. Well, which one's g of x again? Which one's g of x? So that's the log one, isn't it? Will that ever equal 3? It's going to happen at some point. And eventually you'll be able to solve functions that push you to think, all right, well, if you add this and it's claiming it's going to equal 3, that could happen at some point. So I'd say it's true. And just as a sneak peek, this is where it happens for the x coordinate. So it does happen. Capiche? Sound good? Solve each equation, write each answer as a logarithm and decimal approximation. I'm going to do some of these. I'll do the 9, 11, and the 13. Capiche? Sound good? This gives you a chance to get your hands dirty with 10, 12, and 14. So going to log form, you already have your base 10 isolated, maybe some steps. Oh, where's it at? Some steps. Steps. Isolate. Your exponential. With your base. So in this case, our exponential with our exponent of x, base of 10, it's already isolated. So then just switch it back over. Go back to log form. Say that x equals log base 10 of 0.1 And if you run some work on this, you'll see that your answer is just going to be -1. This pen's so weak, such a weak pen. So -1 for that. Maybe take a moment, try 11 while I'm configuring this pen situation. Try 11 real quick and I'll throw some answers up into that in a second. All right, we're back. We should be isolating this exponential function. So you should definitely be moving that 53 to the other side. A little bit of math you'll do on the right side. This leaves you with 10 exponent of x plus 5. And now this equals, what's this going to be? -177. Sorry, -177. Yeah, like that. Peach. No, psych, you're adding it back. Silly. Why'd you fall for that? What's it really going to be? -124 plus 53. -71. Now we're cooking. I knew that was the answer anyway. So now that our exponent or exponential side is isolated, it's on its own, go back to log form. So this should now say that x plus 5 equals log -71. Remember, keep it negative. And we can take this further if you just subtract 5, just get rid of the 5. So you're saying that x equals log, you got an argument of -71, and you're deducting 5 from all of that. Luckily, these are all base 10, so you could knock this all out in your calculator. And if you crunch this number, it's going to claim it's not a real answer. And isn't that upsetting? Such a shame. So just, it totally works when you plug it back in. If you're not convinced, really think about it. But for here, say it's not a real answer because your argument's negative. So that should be a telltale sign that something probably isn't going to work out. It's a shame. And it actually totally makes sense because this is claiming that this whole situation should be some like -71. And there's no way that this can go negative. So stuck. However, with 13, we can do some damage here. Trying to isolate this. First, you should get rid of this 3. Probably the easiest thing to pick on. That leaves you with 4. I see a lot of students try to distribute the 4 into this 10 and whatnot. I would reconsider. I don't know if that's the best approach. Keep them separate. This leaves you 2018. What a year that was. What were you doing in 2018? For your starting value for this exponential function, it's kind of struggling. It's there, so we got to get rid of it. We got to divide. So if you do this, normally I say hold off on this number, and I'm actually going to do that here. So this still leaves us with 10 to the x minus 2 equals this fraction. It's a pretty chill fraction, don't you think? Isn't it ironic? You're now isolated for your exponential idea here. So drop that exponent like it's hot. Your right side is now going to be in log form of, you guessed it, this fraction that's here. And 4 is in there. Pretty simple, just add back 2. As you can tell, this took a little bit of time to write out all the steps. I encourage you to do the same. So your answer gets to here. Your calculator can approximate this a little bit. So let it work its magic. Log parentheses 2018 divided by 4, and then adding on 2 to all that. So this is approximately 4.7. Capiche? Check your calculator, make sure it makes sense. We don't normally have to approximate our answer, but we did here because we are more than capable and we have the power. So it's kind of nice, isn't it? Some of these might be tough and you might have to graph them. And we're going to try graphing some of these in a moment. Maybe not in this section. We might not even have to graph some of these. Maybe 17. 17 you might actually have to graph out. And I'll tell you why. You have an exponential function claiming it's equal to a log or a linear function at some point. Try to graph that out. But in this case, these are both set equal to y, so you can set them equal to each other. Exponential is already isolated, so kick that back as your base and claim that x equals log. Doesn't need to be written, but I'll write it here because I know some of you are still learning this, which is fine. I'm glad you're here. And so x gets you to this number, and you already know that y is this number. So boom, this is your answer. And if your calculator was on hand and you wanted to crunch the numbers, this would say that x is going to be -3. So boom, you got x, you got y, simple enough. 16, I think you're going to have to graph that out. So maybe use Desmos. And I think that's what we'll do in just a second. So sit tight and we'll graph out 16. Okay, back doing some graphing. Hope you're still with us. Thanks for sticking around. You have one function that equals 10 to the x minus 5. Notice minus 5 is not in parentheses. You have 1/2 x and it's negative. You're subtracting 4. You see that they intersect at 0, 4. You might be curious, hey, do they intersect anywhere else? So no, that's it. If this was a positive slope, there might be more than one point of intersection. But in this case, you would just say that 0, 4 is your solution to the system. And of course, you already know it's going to be -4. I don't even have to include that. You already know what it is. Let's see if there's anything else I have to talk about. A little bit of a throwback Thursday. If you're watching this on a Thursday or a way back Wednesday, some long division. You're trying to think what number times 9 will take away a good chunk of 2,179. I'm going to go big. I'm going to do 200. So I'm going to deduct 9 times 200. So I'm getting rid of 1,800 here. Such a chill year to be around. So if I deduct accordingly, this leaves me with 379. I probably don't want to do something in the hundreds, so let's dip down a little bit further. Maybe let's do like, let's keep it simple. Let's do 30, which is going to be subtracting now 270, which now leaves you with 109. You guessed it. And we could probably get pretty close with 10. So you know what, just for kicks, let me do 10. Let me get rid of 90. This leaves you with how much? 19. Then we got to do 2 more. 9 times 2 is 18. So let's deduct 18. This leaves you with a remainder of 1. Let's add these up, get our quotient. So this quotient is going to be 242 with the remainder of 1. And they ask us to write our answers as a quotient and a remainder, show each step. I think that was pretty thorough, don't you think? Can even check on your calculator if need be. And it should be a pretty good approximation. All right, capiche? Sound good? I guess one thing I should note is that sometimes your answer might be written as this for your quotient, and then remainder of like 1/9. Sometimes this is an interesting way that it gets written. Or they might just leave remainder 1. But you know what? I'll actually just keep remainder 1. Capiche? Sound good? Is this helpful? Can you let me know? Thanks for watching. Take care. Brush your hair.